Hello
everyone, thank you for turning up today. I'm Eric Smith, part of a team working in the Department of Geomatics at the University of Melbourne. I think you can all understand what I'm saying. I'm Scots, so I'd excuse if I say the odd wee word that you don't know. Do ask, so that's fine. The three other team members is Professor Ian Bishop and Dr. Ford, Dr. Williams, also part of this project. The title is the Landscape Visualization Tools and Methods and Decision Making with Scenarios. Today I'm just going to cover the introduction, forest management. That kind of gives the theme away today. The application area is in forestry. The tool set that we developed to build scenarios, forested scenarios. We looked at the results. Somebody in future work, where we're going to go with this work conclusions. Put it in context, the work that was done with this project is part of a larger umbrella project called Social Acceptability and Forest Management Options. The work we've done here is phase one, which is development of the landscape options. We can't assess the preferences of landscape options until we actually have built some. So that's what this project phase is about. The study area for the project is in southern Tasmania, in a very beautiful part of the country. Just southwest of Hobart. It's I don't know if anybody actually been here, but it's very lovely forested area, wet eucalypt forests. And the project partner that was supporting this work is Forestry Tasmania, the Forest Practicing Authority in Tasmania, and Tourism Tasmania, so I thank them for their assistance. Let's start off with a couple of quotes that I quite like. Landscape, when people say, what do you mean by landscape? And I said, well, I like to think of landscape as a kind of a holistic approach, maybe not holistic, but more of a whole body approach to looking at what's out there. That's what Farina, I think, was trying to get across when he's saying it's not only about the biophysical components, but social and psychological components also. And the second quote I quite like was from Manda, who suggests that the degree of integration between the different components of landscapes is functionally dependent on the patterns and intensities that these components are applying. And I think this is particularly relevant when you're looking at forestry, which inherently has structural patterns and intensities associated with the harvest management options. So, why is forest management important? Well, previous studies have looked at what the public think about why forest management is important. And there's three basic areas that keep popping up. And one is the adequate and sustainable timber supply from the forest itself. You don't want to harvest the entire forest down and then have to leave it for 90 years, effectively one human life until it regrows. So you have a glut at the start and then nothing for the remainder. You want to try and spread the wood supply out over a period of time. Second item is an ecologically sound environment. It's quite important to supply that. Man isn't the only user, in quotes, of forests. The natural flora and fauna also have a requirement to use the forest as a natural habitat. So it's important to keep the environment sound. And then, from an aesthetic point of view, to create a visually acceptable landscape. As members of the public, we use the forest for recreation purposes, we use it for quiet recreation, we like the visual amenities applied in forested landscapes. So it's important that we have those three components, when we think about these three components when looking at forest management. Yes. What are the forest management options that we're currently? Well, traditionally, you've probably heard of CBS, which is clear fell, burn and sow. That's the most common approach to timber harvesting, and that's where at coop level, anything between 20 and 100 hectares is harvested, and the ground is burnt and then re-sowed. with the species that was there. This is a natural forest management scheme. It's very efficient. It's been used for years, but it's open to criticism because the public don't like to see large tracts of land that are burnt. So there are alternatives that we've been looking at, or the forestry management have been looking at. One is called aggregated retention, and that's where coops aren't harvested in their entirety. There's about 20% retained in little clusters, you can see here. Little clusters of up to 2 hectares, or like little islands that are distributed throughout the coop, and they act as little habitat islands. And they also act as a visual component to break up what you're looking at, or what you're seeing. So you don't see as much of the burnt ground. And the third item is what's called group selection, and the one that we're particularly looking at is Tasmanian group selection. And that's where the strips of the land are harvested at periodic intervals, and you get interesting structural components coming into that. The fourth item is eucalypt plantations, which are highly linear. These are not seeded, these are actual plants that are put in the ground. And that's why you get these rows appearing. So these are the 4 management options. You think, well, 4 is not too bad, but they're applied on different rotation bases, i.e. different frequencies in the landscape. And so it adds additional complication. In total, we have 11 harvest systems that we can apply to the landscape. What landscape? This is the study area that we were looking at. In a previous research, we looked at the acceptability of harvest options on a coop basis, then at ground level. This is not a coop level, this is a coop being up to 100 hectares. This is 66,000 hectares. It's 35 kilometres by 20 kilometres. So we can apply 11 harvest systems to this. This is additionally complicated because there are 3 tenures in this area: National Park and Forest Reserve, State Forest in the sort of yellow, and private land in the white. So there are different regulations associated with the different lands and tenures, which adds additional complications. So, forest management, when we apply timber production techniques to the landscape, they're inexorably linked to both visual amenity or amenity from a human point of view and natural environment. And if I ask 10 people or 20 people in this room what their priorities were with regards to setting priorities on one of these 3 areas, I'm going to get 10 different responses, because everybody has a preference, or has a preference as to what they deem important, with regards to forest management. So, making decisions on future landscapes is quite complicated, both because of the variety of the number of harvesting options, the types of lands, and the priorities that we put on these 3 elements. It requires setting objectives and assessing the priorities of what you're trying to achieve, and then ultimately you will produce multiple landscape options. We term these scenarios. So, what do we need in order to develop landscape options? We need a system that supports public participation. We found that if we can involve the public from the start and they can understand the process of development, we get a much greater acceptance of the end product. A system that supports multiple realisable future landscape options. The scenarios, we need to look at different scenarios. And if we can quantify these options in terms of the wood supply, the natural environment, and the amenity, it gives us a method by which we can compare the scenarios, or at least the public can compare the scenarios. To that end, we produced a data set a tool set called Scenario Builder. And key characteristics were that there was a flexible selection of land areas. We could apply combination harvest systems within those areas. It supported legislative constraints, which assisted with people who wanted to build a constrained scenario, i.e. meeting all the current legal constraints, and those who wanted to build unconstrained scenarios, i.e. do anything anywhere within the landscape. It also supported selectable thematic displays so that the participants could see what they were looking at in any theme that they wanted, either forest age, forest type, tenure, management, anything they wanted to see their built scenario and quantifiable outputs. The system was built on ArcGIS, running on Arc objects. It was deployed on a laptop using a split display system. It had an operator because of the complexity of the data manipulation in the background. And we also wanted the participants just to focus on building the scenarios, not being concerned about how to get the data.